Morning, students.
As far as I know, you have seen how to implement linked list in the last lecture. It can be very simple. So I just switch the screen to um, show you some of the review. And the linked list is can be opposed of an array. So you may think that array is a block, a large block of sequence. So if you have 3 elements in a block, okay, and if you have 2 elements, 2, 3, but you want to add in the in the beginning of the list, you have to shift them. So you have to move 3 here, you have to move 2 here, and then you can insert 1. So this is not so good for a dynamic structure. So in a linked list, you are storing that 2 is stored here and 3 is stored here. Conceptually, they are linked with a small pointer, much like this. And the last one, the pointer contents of the last one is nil. And if you insert 1 just before 2, just allocate a new slot and make a link that to here. So it is much like some tedious sometimes, but it is very good for dynamic structure. So you want to change the structure frequently, then that can be implemented using linked list. So do you have any questions on this? No questions? Okay, then I'd like to switch to the today's contents. So you want to implement a stack. So the linked list can be interpreted as a stack. So it is easy to implement a stack because the last one, you may think about that the last one is here. And if you want to push a new thing on top of a stack, you just make a slot, okay, and push this like this, okay. So when you want to pop, you just eliminate this and re-link this to the stack. So the head of a linked list can be considered as a stack top pointer. So, but in order to print the contents of them, it is very convenient to have a pointer. So let me show you that. Which one? This one? Okay. This may be your first status. And you want to print all the contents of the linked list, then it is very convenient that using a pointer pointing to the first element, and this pointer is if the pointer contents is not null, then it will print 1 here. And you can advance that pointer to here. And if it is null, if it is not null, then you can print 3 here. Okay, and you can advance it further. And finally, it is nil, then it terminates. So this kind of pointer is called iterator in C++ term. So the iterator extends the concept of pointer type in C. So the pointer type in C is extended as an iterator. So iterator is a useful tool navigate the contents of a container. Even though I use this example for an array, that can also be implemented on top of a linked list. So this is a challenging problem for you. But the actual problem is not needed the iterator. I'm just want to exemplify how to implement them. So let's take a look of this code a little bit. So you are making a class range. So if it has some size, it allocates a new array. So think of that you are given range on with 5, then know that ints will initialize, allocate 5 slots, 1, 2, 3, 4, 5 slots inside of the range object. And they are initialized from 0 to 4, 5 minus 1. So 0, 1, 2, 3, 4 are initialized by this for loop. Okay, so it is very normal thing. An abnormal thing is that there is a type which is called iterator. So you know that iterator is a time name. So it is redefined as a time name, but the actual definition of the time name is that like this one. So you may consider that from after the type def, iterator is equal to integer pointer. Okay, so it is type of integer pointer. So you just declare time name, and that time name is used here as a return value of begin, as a return value of end. So the beginning part, as you know, the beginning part of this integer array is that here. This is the beginning part. Okay, and as you know, the array name, it is pointed by integer, so the contents of it is ints here. So the beginning pointer is returned here, and the last one is nothing. So just imagine that there's nothing here. So this is called end. So it will return ints plus size. So it is end. And with this simple setting, you know that you understand everything in this range. Then you can use the iterator from begin to end, like a magic. So R begin, R end, it is sufficient to navigate whole contents of them. So OStream iterator is using cout, okay, and it is printing the iterator, printing the contents of them, okay. So do you know what I mean for the iterator begin end? It is like a pointer. So I show you the same contents can be implemented using actual screen. So, okay. Oh, I'm sorry. I have to switch to the screen here. So, in the data structure, 2020 data structure, that there is a lab 5 stack and as range.cpp. Range.cpp is the contents of this. Okay, it is good to adjust the size of it. Contents of them is the range iterator, and actually this is for renaming that for range iterator. So the type of the iterator is the, or you can range iterator. Iterator P is beginning, R the begin, okay, and P is not R dot end, okay. You are incrementing P, and you'd like to see out the contents of P with separate a new line. So the copy has the same meaning to this. Okay, so let me show you that if you want to compile this G++, what was that? What was the name of this? Range.cpp. It is compiled correctly. So if I'd like to execute this, a.exe in the current folder. Okay, so you are printing 0 to 9. Okay, so this is actually shorthand for this for statement. So let me show you. This is another implementation of copy. So it is copying the contents of it, and OStream iterator is referencing the member of integer, and the integer contents will be printed. Okay, so this is not fully encapsulated, I think. So when you compile this G++ range.cpp, it compiled correctly, and if we execute this a.exe, the same contents. Okay, is this good? Okay. Okay, good. So today's problem. So in order to do that, you know that you are using plus here. So in order to do that, you have to implement the iterator operator plus. Yeah, you have to return this. Okay, operator plus should be implemented. Okay, so you know that P is the iterator. So not actually here. This is a range plus. I mean that iterator plus should be implemented. So you define the type definition as an integer iterator, but you have to make a new class iterator. So it can be implemented inside of this class iterator instead of this. And the class iterator should support operator. So sorry, it is returning iterator. So it should be public. And it should return iterator operator plus. So it should maintain the current status of the iterator. and it should return something here. Okay, so that should be a full implementation of the iterator. Okay, so this is just a challenging problem. So let me just reset it. Reset it here. Okay, to the previous problem. So iterator is a very good thing. So it simplifies the other things to that. One of if you want to, okay, so let me change this. Copy range the CPP range to the CPP and the CPP. So range 10 the CPP. You may want to separate this using a special separator. This one. Okay. Then make range 10. Then the range 10 has a different behavior, and you don't want you just want to delete the last one. That is not possible to here. So in the range 10 the CPP, you can do that. You can do that with so let me just make it so you can do that R and -1 here, R and -1. Then it doesn't print the last element. Okay, so let me just make this range 10 the CPP. Range 10. So you can you see that up to 8 is printed, and the last one should be printed separately. So the last one should be printed Cout of the contents of. So you can just make it explicitly range the iterator is the last element. So you can just point the last element R and -1. So this is more good because it is more readable up to last element, but last element is excluded. So Cout, you just implement last element should be printed with a new line. Okay. Then make range 10. The last one is not printed. Okay, so in order to do that, you have to know range 10 the CPP. You have to know that this minus operator should be implemented inside of the iterator. So in the previous example, I said that public is here, but you know that, and the iterator operator plus or minus with an integer should be implemented like this. So it is not possible, it is nested comment. Okay, so it should be implemented like this. Okay. Anyway, do you have any questions on this code? Questions? Okay, so I'd like to switch it to your PC screen again, on the PDF file again. And note that the class range, can you see this PDF file? Okay. So note that the class range is simulating the unary range of operation in Python. So you know that the Python is not has a special object range 10. It will generate a list, but actually the list is not generated in 3.x. It is implementing using generator. So the generator concept is very similar to the container in the iterator in C++. To generate an array of integers. So, but the array is encapsulated by the iterator. So the begin and end, and you know then you need another operation, operator plus plus and minus or plus should be implemented. Note also that generic function copy, so the copy generic function, for this you just included algorithm. Copy is used to print the element to cout. So using cout, you want to using upstream operator. So you need iterator for this. And you know that cout IOStream should be included for cout using another iterator, namely OStream iterator. So it is actually in the concept that you have two iterators. This is an iterator 1. You have two iterators. Iterator 1, I1. This is another iterator 2, I2. So you know that the iterator 1 starts from begin to the end, just before the end. And you'd like to just copy the contents to here, iterating here. Okay, so it is encapsulated by the iterator. And the tricky one is that special handling for the last element is somewhat tricky. But conceptually, it is just copying the contents of it to the upstream. So any questions up to here? No questions? Okay, good. Then I'd like to explain today's contents, today's problem. So today's problem is stack sequence, the CPP. As introduced in the last lecture, a stack can be easily implemented by a linked list, and I just reviewed it again. And implement a stack using a linked list to detect a stack sequence. The stack is an integer stack, very simple stack. So it is an integer stack. A stack sequence is a sequence of numbers which can be generated from the input sequence using a stack. So every number in the input sequence should be pushed only once in the stack. So stack should be used once for every element. So if you have an input sequence 1, 2, 3, 4, 5, the output sequence 4, 5, 3, 2, 1 is a valid stack sequence. So let me show you. So if you have a stack here, you can operate push 1. So 1 can be pushed here. And push 2. 2 can be pushed here. In the order of the input sequence, 3 can be pushed here. So I followed up to here. 4 can be pushed here. And you are finding that the first element is 4. So 4 should be generated by pop. So 4 is generated here by pop. And push 5. 5 should be pushed here. So actually you are, you are deleting this part. Once you push it, once you pop the 4 element 4, not 4 element. So if you push 5 again, the stack configuration like this. So if you pop, then the contents of 5 is popped here. Pop again, 3 should be popped. Pop again, 2 should be popped. And you know that last one, pop 1. So 1 should be popped. So 4, 5, 3, 2, 1 is a valid stack sequence. So most trivial valid stack sequence is that itself 1, 2, 3, 4, 5 is also a valid stack sequence. So you can think about that: push 1, and pop. It will generate 1. So push 2 and pop. It will generate 2. So this is a valid stack sequence. So another trivial one is just reversed one. 5, 4, 3, 2, 1. How can you do that? Push 5 elements in sequence: push 1, push 2, push 3, push 4, push 5, and then pop them in reverse order. So it will produce the reverse order of it. Okay, but this is not a valid sequence, I think. So 5, 1, 2, 3, 4. Is this possible? Just think about that. I don't think so, but just think about that, because if you want to push 5, then this sequence, even though this is a valid stack sequence for 1, 2, 3, 4, it is not possible, because once you push 5, then every other thing should be lied inside of the stack. Okay, so you have to think about that. So the input consists of 2 lines. The first line of the input contains a positive integer n, so which is the size of the elements. And the second line contains n positive integers where the following condition holds. So it seems somewhat tricky, but I just want to show you that this sequence is a permutation from 1 to n. So this is called a permutation. You know the permutation from discrete mathematics. Okay, so it is an arbitrary reordering of the numbers from 1 to n. So I just make it explicit that, in other words, this is a permutation of the sequence. So your program should determine the given sequence. So the given sequence may be a valid stack permutation, valid stack sequence, or not. So a valid stack sequence from 1 to n, print 1 if it is. If it is not, print 0. So let me show you some example. So here you have, this is just an example as before, so it is a valid stack sequence. And this is another example. So assume that you are pushing 1, you are pushing 2, and you are pushing 3, okay, because your input is always given 1, 2, 3, up to n. So in order to generate 3, you have to pop this 3. So 3 is valid. Up to here it is valid. But how can I pop 1 rather than popping 2? So this is not possible. So you will generate 0. Okay, so this is an invalid stack sequence. Got it? No? Sumin, when did you type it? In secret? No. So you have something to ask. So let me show you why this is a value stack sequence. So you can push. So is it the same as before? Let me just 4, 5. So I just exemplified here. So it is the value stack sequences as explained before. Do you want more explanations for that, Songchan? Should I explain this again? Okay, so it is not so complicated. Okay, so you understand. So any other questions? Leftmost one is the beginning. So, okay, let me make it clear. So 5 means your input is given as 1, 2, 3, 4, 5. Okay? And if your question is that this is the leftmost one, that is correct. Okay, so you are pushing 1, pushing 2, pushing 3, pushing 4, and you can pop this. So 4 is generated. And pushing 5, and you can pop this. This was generated. Pop, pop, pop. This can be generated. So this is a value stack sequence. So I cannot catch what is your exact question. But if it is for the output, it is correct. But if it is for input, it is not explicitly stated in the question. So if you don't have any further question, thank you all for joining this lecture and see you next time. Bye bye. 수고하셨습니다.